Welcome everyone to this video lecture. In this video lecture, I'll be showing you how to draw an equivalent mechanical system to its equivalent form in electrical analogy using FV. Using force voltage analogy, how to convert a mechanical system into its equivalent electrical form. As told previously, if we are employing force voltage analogy, here if you observe in equivalent mechanical system, the force acting on or force applied on different elements are different. So when we are trying out or plotting out FV analogy, the voltages which we have to draw should also be different. And voltages will be different in series circuit. When circuit elements are connected in series, the voltages with respect to those circuit elements will be different. So in FV analogy, the circuit elements should be connected in series. So let me explain you how to draw equivalent mechanical system into its equivalent electrical system using FV analogy, force voltage analogy. As already told, in FV analogy, we already know that mass is analogous to inductance. The damper coefficient is analogous to resistance, and the spring constant is analogous to inverse of capacitance. So if we remember these three, it's enough to draw the equivalent FV analogous electrical network. So let us start with it. Because we have two displacements, x1 as well as x2, we definitely will have two displacements, or two meshes, mesh M1 and mesh M2. Two meshes will be there. If there are three displacements, there will be three meshes. If there are n displacements, there will be n meshes. The circuit elements should be connected in series. That is very important. With respect to node x1, if we observe, force is applied to node x1. M1, K3 and B1 is completely under the influence of x1. The same thing is replicated even here. Similarly, with respect to x2, if we observe, M2, K2 and B3 is completely under the influence of x2. So it is written with respect to mesh M2. K1 and B2 is between x1 and x2. So that will be written as common elements between mesh M1 and M2. Let me make this point clear. As I told you, there are two displacements, hence there will be two meshes, M1 mesh as well as M2 mesh. The circuit elements will always be connected in series over here. When we are drawing equivalent electrical network using FV analogy, it is better to identify the common elements first. If we observe between displacement x1 and x2, we have common elements K1 and B2. Electrical analogous to K1 is 1 by C1. Electrical analogous to B2 is electrical analogous to B2 is R2. As I told you, K1 and B2 are between x1 and x2, which should be between two meshes M1 and M2. But these two, K1 and B2, are connected in parallel with respect to our mechanical system. But when it comes to FV analogous circuit, those two should be connected in series, as already discussed. So 1 by C1 and R2 will be connected in series, which is the common element between mesh M1 and mesh M2. So once we have identified the common elements, writing the other elements becomes very simple to us. In place of force, we write voltage because force is analogous to voltage. Next, in place of mass M1, K3 and B1 is completely under the influence of x1. In place of mass M1, I'll be writing as L1. In place of K3, I'll be writing it as 1 by C3. B1 will be written as R1. These three mechanical elements which are connected in parallel in equivalent mechanical system will be connected in series in voltage or in FV analogy electrical network. In place of M1, I've written as L1. In place of B1, I've written as R1. In place of K3, I've written as 1 by C3. Instead of writing it as 1 by C3, I've just represented it as C3. It is nothing but C3 is equal to 1 by K3. That's it. If K is equivalent to 1 by C, C will be equivalent to 1 by K. So C3 is equivalent to 1 by K3. Next, similarly, if we observe with respect to X2, the node called as X2, M2, K2 and B3 are completely under the influence of X2. Hence, in place of M2, if we plot out FV analogous circuit, M2 is analogous to L2, B3 is analogous to R3, K2 is analogous to 1 by C2. Or in place of writing it as 1 by C2, I can write it as C2, which is equivalent to 1 by K2. It is just a way of representation. So these three mechanical elements M2, K2 and B3, which were connected in parallel in equivalent mechanical system, will be connected in series when we convert them to electrical analogous network, electrical analogous system. So in place of M2, L2, in place of B3, R3, in place of K2, 1 by C2, which are connected in series. And because we have two meshes, there will definitely be two mesh currents, I1 and I2. So this is how we draw equivalent electrical network using force voltage analogy. I hope that you have understood this video lecture. Thank you.